What is going on YouTube? Welcome back to another video. So in this week we're going to talk about client adapting APIs. So we're going to learn how to identify the client type and also how to make our API responses flexible. So let's get into it. So to introduce this, in the real world, an API endpoint gets called by numerous types of end devices, such as mobile phones, laptops, tablets, and so on. And depending on the type of end device or situation, API responses can be flexible. For example, a YouTube video resolution provided by the server is different for a mobile device compared to a desktop browser, and this can be due to the width of the screen, transfer protocol, and so on. Therefore, an API generating the same response for every client request may not be suitable for all end devices. A flexible API response refers to the flexibility in terms of the response generated and resources provided by servers to clients, mainly depending on the user and client, such as its type, version, and so on. To generate a flexible response, we need to provide flexibility on the client or server side. We'll discuss different ways to make the response flexible using various examples in this lesson. So here are some approaches. Adaptive responses can be achieved in the following ways. So we can provide flexibility at multiple places to generate a flexible response, such as the client side and the server side. So for client side flexibility, this makes responses flexible on the client side before displaying the results on the screen. We get the same response for all user scenarios or different client types, and the client tailors this response according to the requirements. All the clients receive the same number of fixed fields as a response from the server. So for example, this web page uses 4 images for small devices and 8 images for large devices depicted in the following illustration. And although the response from the server remains the same, 8 images are received for both devices, the front end displays 4 images to make it look more suitable for the device's smaller screen. And generally, if we use a large number of fixed fields in the response, then some of the fields might not be necessary for some clients. On the other hand, if we use few fields in the response, these fields might not fulfill the client's requirements. Although the number of fields can be changed over time, it remains the same for all the clients. This approach works fine in some cases, but it doesn't provide flexibility for varied user scenarios or client types. Next, we'll discuss server-side flexibility for getting a tailored response from the server depending on different user scenarios and clients. So now we'll talk about server-side flexibility. Server-side flexibility makes the responses flexible on the server side based on the client or user scenarios. We discussed the 3 approaches for achieving flexibility on the server side as given below, such as intermediate adaptation code, expanded fields, and GraphQL. So intermediate adaptation code, IAC, is a technique used to obtain server-side flexibility. And for client identification, identification of the client is important because it helps the API gateway decide which downstream services to call. Client identification is mainly done through the HTTP headers. Generally, 2 types of HTTP headers serve this purpose, such as HTTP user agent and HTTP client hints. So HTTP user agent, the HTTP user agent header is a string that allows servers to identify the client OS vendor and version. This header is defined in the following way. We have the user agent key, and then you have the product version, and comment. So the product identifies the name of the client, such as Mozilla. The product version provides the version of the client, and the comment, this is optional. We can use it to add details related to the operating system and more. So the HTTP user agent, for example, the macOS user agent string looks like this, as you can see in the picture below. The string above is long and unstructured, which makes it difficult to parse from a developer's perspective. Sharing detailed information about a client in the HTTP request creates privacy issues because we need to prevent users from covert tracking, such as digital fingerprints. To overcome these issues, HTTP introduced client hints. For example, the accept.ch header may contain the following information as seen below. The client then sends information to the server in the subsequent requests. This information includes the RTT round trip time, with the device's width, and the SecCHUA platform, a platform such as Windows, Linux, or Mac. So, Netflix, a use case of IAC. According to Netflix, the one size fits all OSFA REST API approach has serious limitations. The OSFA API treats all devices as the same and generates the same response regardless of the device type, which is also the same as client side flexibility. Therefore, Netflix decided to use the IAC approach and customize its API because every client has specific properties such as its processing power, screen real estate issue, and whether or not chunking is required for the content delivery, and so on. So let's take a look at the following illustration to observe how Netflix works before and after adding the IAC to the architecture. Let's say a device opens a Netflix main page, and on the back end, multiple requests are sent to the OSFA API. And then the OSFA API retrieves the data from the different services and formats and delivers it to the client side. And the client adaption middleware receives a single call to a unique URL device specific that determines the client type, parses the request, and expands it to multiple requests. These requests are sent to the Java API, which further sends these requests to the corresponding services to get data. And then the Java API aggregates the response and sends it to the middleware. The client adaption middleware tailors the response according to the device's properties and sends it back to the client. To handle the different devices, Netflix uses the extra layer between the client-side code and the API where the client adaption code is written. This layer uses the customized endpoint for the specific device and tailors the data according to the client. Netflix uses different IACs for tablets and mobile phones to reflect device-to-device differences. What are the two main responsibilities of IAC? Following are the two main responsibilities of IAC. Client device identification. IAC identifies the client in various ways, such as using HTTP headers, forward the request to the appropriate API gateway to generate a flexible response or tailor the response based on the client type. Expandable fields are used to request the expanded version of certain objects from an endpoint. Depending on the client type or any user-related scenario, we can request additional information through conditional parameters in the URL. Let's understand this by using the following hypothetical example of a restaurant finder application. There are two different devices accessing the same endpoint of this application. The devices exercise conditional parameters to request the following expanded object. So on a mobile phone, when the get finder location endpoint is called via a mobile phone, the following response is obtained, like we have the location, places, ratings, images. And on a web browser, next we need to expand the image field for the web browser. The endpoint is get finder location expand equals images, which gives the following response, which gives us some more images. So the API generates the response according to the expand parameter. Any client desiring to receive expanded objects will need to add the expanded parameter depending on the type of end device or user-specific requirements. On the server side, we achieve flexibility using the single endpoint. GraphQL is another great technique for generating flexible API responses. Using this approach, the client defines their requirements as a query, and the API generates a flexible response according to the client's requirements. This approach requires the server to share a schema with the client beforehand. The schema defines the structure of available resources and the client's request format. Upon receiving the client's query, the API makes a single call to fetch the data from different services to meet the query's needs. Take the example to the right of the Restaurant Finder application. If we want to know additional information about the peak times to visit a restaurant, GraphQL is useful here. Instead of making a separate call to get the peak times, we send the query to the server in the following way. So we have a query, the location, we input the actual location, place, images, ratings, and we also can put the popular times in with the timings. And the following response is obtained from the query. So we have the data, the places, and we also have our timings. And we can conclude that by using GraphQL, we don't need to send multiple calls to retrieve the required data from different APIs. GraphQL provides flexibility using a single request to receive data, such as location and popular timings from different services. The mechanisms for providing the flexibility we discussed in this lesson are not exhaustive, but it gives some idea of how we can make an API response adaptive. In the sections before, we discussed some approaches to achieving flexibility in API responses. However, making API responses flexible may not always be a fruitful effort. This section discusses the advantages and disadvantages of achieving flexibility in API responses. So the advantages: improved design of the application is achieved by choosing the optimal end client or server to perform the processing. Enhanced performance of the overall application is achieved, which leads to a better user experience, and it may result in the efficient usage of bandwidth and other client or server side resources, memory, processing power, and so on, because only the required data is communicated between the two ends. So the drawbacks: adding flexibility to API responses leads to added complexity. For example, an IAC layer requires extensive and optimized coding solutions that should handle all types of devices or different user scenarios. Achieving flexibility in API responses introduces an additional financial cost for the service provider. For example, an additional number of endpoint management will multiply the expenses. In summary, in this lesson, we saw how we could tailor API responses as per a specific use case or client device. Often our primary goal is to provide the client with a better experience and efficiently utilize computational resources. Let's consider an application that provides chat services for almost every size and version of the device. We also want to add less load on the client side, and size or version compatibility should be handled on the server side. What would be a good approach to handling this scenario? So the answer to this is B. IAC helps us identify the client type and its version and forwards the request to the appropriate API gateway to retrieve the customized data according to the client's requirements. Thanks so much for watching. Hopefully you liked this video. If you did, leave a like and subscribe. And if you have any questions, definitely leave a comment. I definitely had a lot of fun making this video and learning about this topic. And, I'll see y'all in next week's video. If anything, have a great rest of your week, and I'll see y'all next time. Peace.